All right, so it says Mr. T ignites the enthusiasm of the class. The homemade cannon demonstration. A tennis ball is coming out of this cannon. So we have, so this is a firing type problem. So if I'm going to do this, I want to list my facts. Now, remember I told you that the generic things is to use M1, M2, V1, V2. But if you want, you can use letters also. And for this problem, I'll use letters just to use something different. So I've got a cannon and I have a tennis ball. So I'm going to use, for the mass of the cannon, I'll use MC. And for the mass of the tennis ball, I'll use B for ball. That way I'm less likely to make mistakes when I then get down to writing down the velocities, where I don't want to mix up the M1 with the V2 velocity, or the M2 with the V1 velocity. So if I use letters, I'm probably less likely to make that mistake. You don't have to do it, but you can if you think it's easier. So mass of the cannon was given in the problem as 1.27 kilograms. And the mass of the ball was given in grams. So since I've already written my cannon in kilograms, I'll use kilograms as my unit. So if I write that in kilograms, that would be 0.054 kilograms. So there's the mass of the cannon and the mass of the ball. The velocity of the cannon to begin with and the velocity of the ball to begin with before the explosion are what? Before the explosion, they're both zero, right? Neither one is moving. So we're going to have 0 meters per second for both the cannon and the ball. And then after, we have velocity of the cannon after and the velocity of the ball after. So they're going to have to give me one of those, and I'll be solving for the other. So it says the explosion stuns the crowd. A photogate measurement determines that the cannon recoiled backwards with a speed of 7.8. So recoil means it's going in the opposite direction compared to the other one. So the velocity of the cannon, that's going to be negative 7.8 meters per second. And so they're going to have to ask then what was the speed of the ball? So that's going to be in meters per second. So if you have what I have on the board, that's going to be 6 points for the facts. Now step 2 is to write the equation. Now, since I'm writing it in terms of B and C instead of 1 and 2, I'm going to write my equation as MB VB plus MC VC equals MB VB prime plus MC VC prime. And I could have put the C first and then the B. It's the same equation. So that's the law of conservation of momentum. Now, since the velocity of the cannon and the ball before the explosion were 0, it makes this really simple because 2 out of my 4 terms cancel out. And then I just need to solve this for the velocity of the ball after the explosion. So I'm going to move that to the other side and divide by that. So step 3, the velocity of the ball is going to equal minus MC VC after divided by MB. And so that's going to be VB equals minus that over MB. So the mass of the cannon was 1.27 kilograms. The mass of the ball is 0.054 kilograms. And the velocity of the cannon was minus 7.8 meters per second. So notice that I have a minus that's part of the formula, and I have a minus that's part of my fact. So that's why you put those parentheses in and then worry about what the values are. So I know that any minuses outside the parentheses are parts of the formula, and any minuses inside are part of the facts. And I say that because, we just had that lab, and a number of people, when they were using those formulas for range and for time, especially the one for the one for the range, which was VO squared, if they had put parentheses squared, the square would have been outside the parentheses. But some didn't even put parentheses. They just wrote the number, and then the square looked like it was just part of the unit. Or they put the square in next to the number, which needs to be outside so that the units are also being squared, not just the number. So in solving this, I guess the answer came out to be, what did I give you for that? 183. So 183 meters per second. Any questions with that?